So good morning, everybody. Thanks for coming early on a Wednesday. I'm sure everybody's all partied out already from SIGGRAPH, but cheers to you for showing up at 9. Okay, so let's dive right in. So we're going to talk about both the WebGL and the WebGPU APIs here, and got a pretty solid agenda. And you don't have to take pictures of any of these. They're going to be posted like right after the session. They could be posted right now. But anyway, you can all, there's a khr.io link here. Oh, I lost it. Okay. These are actually already up on a short link. It's khr.io/WebGL SIGGRAPH 2024 or something. But anyway, don't worry about taking pictures. You'll have all the links, all the slides. Okay, so first of all, by way of news, who's familiar with the WebGPU API? Okay, good. So like more than half of the audience, good. So it's being developed over at the W3C, not at Khronos, but Khronos generously hosts both WebGL and WebGP meetups here. Appreciate that. Khronos liaises with the W3C, and actually a lot of the basic technologies that went into WebGL and made it fast are similar things making WebGPU work, like the ability to do numeric computation in JavaScript and upload buffers to the GPU. All that stuff carries over and was actually created at Khronos. So we don't want to Osborne WebGL. Anybody know what Osborning is? Neil Ree introduced me to the term, but the Osborne was an early UK computer, and they had a majority of the market. And they announced, ooh, the Osborne 2 is coming out. It's going to be really, really good. And all the entire economy just stopped buying the Osborne, waiting for the Osborne 2. And the company's revenues tanked and they went out of business. So we're trying to not Osborne WebGL here. It's going to be around forever, all right? We will never remove it from the browser so you can use it with confidence. And it's everywhere. WebGL 2 is everywhere. You can really upgrade, I think, from WebGL 1 and the proliferation of extensions with good confidence at this point. But WebGPU is up and coming, and we're going to talk more about like the state of that specification and the various implementations later. Okay, so the WebGL ecosystem has been evolving a bit. There are about 14 new WebGL extensions that were developed over the past year or so, thanks mainly to Alexei Knyazev, who's an independent but works a lot with Khronos. And he basically poured through the OpenGLES extension registry, found all the useful ones that were kind of low overhead to implement, and now they've been implemented in WebGL. So all of these have been raised up. A few of them have had name changes like clip call distance, even render shared exponent, because they were trimmed down from the native specifications a little bit to be more portable on the web. But basically, these are all in Chromium or Chrome right now. They are coming to Safari 18. They're in Safari Tech Preview now, and hopefully many of them will come to Firefox as well in the near future. So these should help you, enhance your apps, speed them up. The clip control extension helps you convert between coordinate systems like WebGLs and Vulkans, which is pretty much the same as WebGPUs. So if you're trying to get your code ready to bring over to the new API and get your cameras right, this is a great way of testing that and getting one code path that runs across all the APIs. So anyway, thanks very much to Alexei for driving these. Really appreciate you. Okay, so for a while now, we've been working on a new backend for WebGL on Mac. So in both Safari and Chrome, we're using the Engel project, which is an OpenGL ES implementation. And we've removed the OpenGL backend and have slotted in a great new Metal backend that was started by Kuyen Le from now Google. We're glad that he joined the team. And so this is still ongoing. It's actually been a difficult road to get it running or shipped in Chromium because the entire browser's rendering stack is hosted on top of Engel right now. So you got Skia, the browser's rendering library, doing all the SVG and HTML rendering. It got an OpenGL backend. And we're slotting in Engel underneath it. Actually, that's already done. And now we're trying to replace OpenGL at the bottom layer with Metal. Now, the Metal backend is way faster than the old OpenGL backend for a lot of content, and basically including most WebGL content. But when you're trying to change the entire browser's rendering stack, including, like, I don't know, the stencil-based clipping that Skia does and everything, it's really hard to beat it on, like, every benchmark. And with Chrome's pervasive user base, any regression is treated as, nope, can't ship. So we've been having quite a difficult time getting this out the door. It's already shipped on Mac with Apple Silicon, and it's being shipped now on Mac with Intel GPUs. This is already shipped for a long time in Safari. So anyway, that's the situation. Alexi untangled some dependencies in the backend and got non-blocking program linking implemented there. So KHR Parallel Shader Compiler works really well on Mac now. Thank you, Alexi. So Shader Toys will load faster, and if you're using this in your apps, you will get faster startup time, and you can be more interactive. So anyway, also thanks to Alexi, he debugged some crazy behaviors in texture sampling and other stuff, figuring out, I don't know, like the texture projection primitives in Metal working a little bit differently than OpenGL. And he's like, oh, well, all you have to do is compute the partial derivatives with respect to the surface. I'm like, okay, great, I know those words, but how do you do that? By transforming all the user shaders coming in. He implemented it, now it's passing the entire DQP and all of the WebGL 201 conformance tests, which are, it's a really large conformance suite. This is the first platform that is passing 100% on. So thank you, Alexi, for proving that the conformance suite is actually passable, and now we're gonna try to get it passing on more platforms and finally ship the next dot version of WebGL. Okay, so that's that. I've discussed this previous meetups, but Chris Dalton from Rive spearheaded a pixel local storage extension, and this gets you basically fully programmable blending at various performance, levels across platforms. So it's super fast in Apple Silicon. Kudos to the Apple engineers, and it's got really good performance on most other platforms, and we'll keep tuning it after the initial launch. Thanks to Alexi for uncovering a ton of corner cases, like what happens if you have a 3D texture? Can you use pixel local storage with like a 2D slice of the 3D texture? We had to cut down this PLS extension, whittle it down, define the error behaviors, et cetera, et cetera. But the spec's almost ready for shipment. You can try this today in Chrome Canary, and the blend equation advanced. All of those equations are implemented in an online demo today. So we're not going to ship blend equation advanced in WebGL ever. There's too many driver bugs out there, but we will ship this, and then you can just implement it yourself, which is even better. So anyway, all these links will work for you in the matter of an hour. Just go onto Cronus' event page, and you'll see these slides. Click them. Everything's open source. You can see how to do this stuff. Okay, so that's pretty much it for the WebGL side. Let's talk about WebGPU. So for those of you who do not know, this is a new modern graphics API for the web, and it also includes portable compute shaders. It's a lower overhead API like Vulkan and D3D12 and Metal are. It's mostly stateless, unlike OpenGL, and so draw call overhead is a lot lower because you don't have to keep revalidating the OpenGL state. And this is really the foundation for all future features on the web, like bindless, like ray tracing. We want to get all these, exposed up to the web portably, and let you application developers make really awesome, fast stuff. Okay, so anyway, the development here is happening again at the W3C. It's all open. The spec repository is on GitHub. You can file issues. Please do, put up pull requests, and please get involved. Talk more about how to do that later. Okay, so what's happening with the ecosystem? It's really solidifying. Firefox Nightly and Safari Technology Preview have WebGPU support today. So it's a great time if you've been trying out WebGPU stuff, try it in the other browsers. Most stuff should already be portable. There may be areas where the implementations aren't complete, and that's where, again, you'll see behavioral changes in your application. But the conformance suite is really solid. It covers every aspect of the API, every aspect of the shading language. So I think you can be confident that, again, the spec will be portable between all these browsers, and the implementations are very, very different. So you're going to have good variety and be, again, assured that we're not over-specializing to one implementation. The spec is nearing candidate recommendation, and I see a few of the usual suspects in the audience. Sorry that I didn't invite you up earlier, but we had some technical difficulties. But if you wouldn't mind waving, I can see Brandon and Kai and Shrek and some other folks. And are there any other browser implementers here who attend WebGPU regularly? No? Okay, well, anyway, there's at least 4 of us in the audience that are working actively on the spec, so please come talk to us afterward and ask any questions that you like. But the spec is moving ahead. We're trying to get to a candidate recommendation stage at the W3C, which is a necessary milestone, then we'll transition it to a living standard, so it'll just keep evolving backward compatibly. And there's been a lot of ecosystem progress, including Three.js's WebGPU backend, which I'll show more later. So, in case you didn't know, there's a ton of excitement for WebGPU in the web AI space. So Hugging Face has a library called Transformers.js that basically lets you take most of the models on their site, is that an accurate assessment? Some anyway, and run them locally in your web browser. And now you can accelerate them with WebGPU. And the way that this works is Microsoft said, hey, we have this Onyx runtime, and loads in Onyx models, and we'd really like them to go faster. And so they worked with Intel to get a WebGPU backend for the Onyx runtime, and that's what Transformers.js is using behind the scenes when it's running locally and trying to accelerate via WebGPU. So this is really cool. They've got like speech recognition, inferring depth from a single image, background subtraction, segmentation, all these models running in the browser. So you don't have to pay server costs. You can send a moderately sized model down to the browser and provide this functionality in your web applications. So it's really, really cool. All these links, again, will work. You can check out Zenova's updates. And if you just search for WebGPU on Hugging Face, you can actually find lots and lots of workspaces that are already working with this. So it's very cool, and we are adding more primitives to the shading language over time to keep accelerating the stuff needed for fast AI inference. Okay, so now some really new news. Never before seen, folks. Get excited. All right. So Google's Android team is going to be launching Kotlin bindings for WebGPU over the next several months. And these Kotlin bindings will be the main way for Java and Kotlin applications to use WebGPU on Android. And they'll also be available on other platforms via Kotlin multi-platform. So initially, this is going to be offered as an Android Jetpack library, but the plan is to integrate it deeper into the system. So what does this mean if you're an Android developer? Well, if you're a high-performance game, or like you're written in C or C++, use Vulkan, at least for now, okay? There are plans, and we can talk about them after the BOF. Vulkan is powerful, it's scalable, and it gives you full control over the GPU. But if you're like a sort of a regular application and need to use graphics, we recommend that you use WebGPU. It's also powerful, scalable, and easy to use, and you can write it once and run almost everywhere. And if you're doing compute, like we just discussed, really you should be building on WebGPU on Android rather than through OpenCL for long-term support and expansion of capabilities. So, we've got a good roadmap for this stuff going forward. We think that this is a simpler way of getting 80, 90%, or maybe even more in some cases, of native speed. It's hard to get barriers right in Vulkan. They don't exist in WebGPU, and they're optimized in the back end. So again, we really recommend take a look at this. I don't know whether the bindings are out there in a compilable form right now. I think the code generator, at least, is already checked into Dawn. But watch for the Jetpack library coming out. We're super excited to hear your feedback and see what you build with it. Also, the Android team wanted me to say that they're going to try to steer new content away from OpenGL ES on Android. Instead, OpenGL ES will be supported on top of Vulkan through the Angle project. So Angle's an OpenGL ES implementation. There's already a Vulkan backend. It's really fast. And that is going to be the way, through a layered solution, that you'll keep getting OpenGL ES and ultimately WebGL. Okay, now let's talk about some fun stuff and see some cool demos. All right, let me see. Is it going to work? Yes, it works. All right, so here is, Here's compute-based rain with particles falling down from the sky, all their motion simulated in a compute shader. All right. And here I'll show you a performance bug. All right, so this thing runs at like 120 frames a second on Apple Silicon, so we need to debug this. Something's clearly going wrong. But here is semi-physics-based particle system, again in a compute shader with WebGPU, and hooked into the whole rest of the Three.js framework. Sorry, I didn't know that this performed so badly until 5 minutes ago. But there's a bunch of other demos on Three.js's examples. So if you just go to threejs.org/examples and just search and page for WebGPU, there's a whole bunch there already. And several of them are using compute. And check it out, all right? This is the code, async function animate, and then await render.compute async. Yes! All right, finally, compute in Three.js on the web. It's very, very exciting. So there's been a lot of progress here. If you didn't know, Three.js is really the most popular 3D library on the web by a long shot. And so we've been encouraging and helping guide contribution efforts here to make sure that it evolves and has a solid WebGPU support. So there's a new Three.js shading language going along with this new WebGPU renderer, because all the materials used to be written in GLSL, and that doesn't really work for bringing stuff forward to WebGPU. So the developers made a shading language which is abstracted between actually the WebGL and WebGPU backends, and a new node graph material system and a backward compatible material, so that if you're just using WebGL today, you can basically say new WebGPU renderer instead of new WebGL renderer, and most code, if you didn't write GLSL shaders, will just work. And one sort of remarkable thing about this is the WebGPU backend actually has a WebGL2 fallback. So even when you switch over to the WebGPU renderer, you can actually get most of your stuff running on top of WebGL2, and you have to test it because not everything works. But this is a bridge to make it possible for people to migrate their apps now without fear of losing a lot of audience, and then it'll just like get faster and better as more browsers ship WebGPU. So anyway, this is a major re-architecture of Three.js, and the team is aiming for a first official release of this later this year. So the online documentation doesn't contain the WebGPU backend yet, but all the sources are checked in, and you can dig around and take a look and try them. Everything, again, works, and the examples already have the WebGPU stuff up there. So I wanted to thank Sunag on GitHub for driving this work in particular, and there's a lot of other contributors whose names I don't know, and follow Three.js for the team's latest updates. So let's get out there and write more web apps using Three and WebGPU. Okay, now other stuff that's going on, the WebGPU samples, like the semi-official repository, has been refactored to use iframes. So all of these little demos and some bigger ones on here are actually hosted potentially on different sites now. So you can contribute very, very easily to this. You can actually have your demo on your github.io site, and then we can just federate it into this little harness here. And we'd love to have more samples, basically, so please do contribute. This one's not interactive. All right, let me see. Oh, here's a couple of external ones. This is yours, right, Brandon? Yeah. All right, so this is render bundle culling, right, on the GPU. Awesome demo by Brandon back there. Please go ask him how it works. And you can see on the right side that actually, depending on the camera orientation, a lot of these render bundles are actually being culled. And this is done on the GPU very cleverly. You can now do these kinds of techniques on the web. So please do bring your awesome content to WebGPU into the web. Okay. Anyway, we accept contributions here gladly. So please either contribute more samples or write your own and contribute a link to them here. And let's get lots of cool content in front of more developers to show them how the API works. And that's actually caps lock, not control. Okay, here we go. Yeah. Okay. I pretty much already talked about the implementation status, so I'm just going to skip this slide. All right. Partnerships. As mentioned, we're working with the Three.js folks. Babylon.js also has a great WebGPU backend, and Play Canvas has a WebGPU backend in progress, and they have some really, really cool lighting and other demos already up there. They also have a really cool Gaussian splatting implementation that they presented at the online WebGL meetup last week. That one's currently hosted on WebGL, but I'm sure will be coming to WebGPU soon. So again, lots of cool techniques coming to the web with WebGPU. We also, in case you didn't know, have a long-standing collaboration with Unity, and they've been building a WebGPU backend as well. So now you can take your game and just say export to WebGPU, bam. And it's fast, and it's got more functionality than the WebGL backend ever did. It's got GPU skinning. It's got the VFX graph. So basically, we're trying to get to feature parity with native and make it possible for you to get more eyeballs on your games, because the web is much more frictionless than any app store. So one click and run. It's really a very powerful medium. Okay, so there are some resources out there. I'm sure this list will grow. Our colleague Greg Tavares has been writing WebGPU Fundamentals, which is a really good course on how to get started with it. And again, our colleague Brandon has been writing WebGPU Best Practices and really good stuff like how to write an efficient GLTF loader and renderer, and how to organize your render loops. And you got to do it differently than you did in WebGL, but when you get when you understand the concepts, it's actually very straightforward. Okay, so please contribute. I'm going to skip over this. There's plenty of ways for you to help and get involved. And we really encourage you to join the communities. We've got a WebGL developers list where anybody can post job postings, demos, questions, anything. Please do. There's a matrix chat room both for WebGL and WebGPU. The links are here in the slides. So please, get involved and ask lots of questions and contribute. Same thing for WebGPU. Got another matrix chat room, and it's even easier to get involved with the specification process because this is really done, entirely with the W3C's framework in the open. And we're all looking forward to hearing from you. And so please, if you have time, stay after the BOF and let's chat about what you're working on and what's working well and what's not. And I think that's it. Yes. Okay. So now I'd like to introduce Stephanie from Binomial, and we have some very, very exciting updates for you about HDR.